So what is the meaning of probability density function? Probability density function or probability distribution function, or we in the short we call it PDF. Okay, so if a function f of x satisfies these three properties, so property number one was f of x should be greater than equal to 0. Second property was if we do integral for all possible values minus infinity to plus infinity, okay, then answer should be 1. And third property was if you want to find the probability that the random variable will lies between a and b, then we can find it by doing the integration from a to b of the f of x. Okay, so these were the three properties of the probability density function. Let us do understand these with help of some example. Okay, so let me give you some example. The shelf life in days for bottle of certain prescribed medicine is a random variable. So in the first line, what they are saying, the shelf life in days for bottle of certain prescribed medicine is a random variable. So first of all, you have to note down what is a random variable here. So random variable we denote by x. So x is shelf life in days for bottle for bottles of certain prescribed medicine, or you can say medicine. Okay, so x is shelf life in days for bottle of certain prescribed medicine. And what we are given the density function f of x. So f of x is 20,000 upon x plus 100 whole power cube when x is greater than 0, otherwise it is 0. Now what we have to find? We have to find the probability that bottle of this medicine will have shelf life at least 200 days. Okay, so at least 200 days we have to find what is the probability that the shelf life of this bottle will be at least 200 days. So what should we write here?
Sir, it would be
So
greater than or and equal to 200 days.
right. So we have to find what's the chance that shelf life of this bottle of medicine will be at least 200. It means greater than or equal to 200. So either 200 days or more than 200 days, right? Now, how we find probability for the continuous case? Because the density function is given, so we find the probability using the integration. Integration from where to where? Now, minimum value is 200. 200. And what is the maximum value? Any value greater than 200. All values are allowed. So maximum will go till infinity. And we'll do integral of the probability density function. This will give us the probability. So what I'm using here? I'm using here this third property. So everyone can see if we want to find the probability that x is between a and b. So we have to do integration from a to b of the probability density function. So here the density function was given and we were asked find the probability that shelf life of the medicine will be at least 200 days. So we have to find what the chance that x will be greater than equal to 200. So greater than equal to 200 means minimum value is 200 and maximum can be anything. So till infinity. Okay. Now, what is the function? So we have to do integration from 200 to infinity. The function f of x, you can see here, the function is 20,000 upon x plus 100 power 3 when x is greater than 0. So here, because we are doing integral from 200 to infinity, so which is greater than 0, so we can write here 20,000 divided by x plus 100 cube with respect to x. 20,000 is constant. 20,000 will come out of the integral. Okay. and this is integral of x plus 100 whole power minus 3 with respect to x. Okay. Now here we are going to use some formula of integration. Okay, so I have told you that you don't need to know lots of formula. Three or four formulas are sufficient to know. Okay, so first one I have told yesterday. The first formula that I have told you should know is what is integral of x power n. So that is x power n plus 1 divided by n plus 1. This is the first formula that every student should know. If you want to clear this course, at least this much you should know. First one. Okay, second is if we have this kind of situation where we have ax plus b power n. Okay, the factor should be linear. Linear means power of x should be 1. Okay, so in that case, what is the formula of integration? Same formula. First, we will increase the power. So ax plus b, increase the power n plus 1. Then divide by this new power, that is n plus 1. And you have to divide it by one more thing here, that is coefficient of x. The coefficient of x here is a. Okay, and both of these formulas are valid for all the power n except n is equal to minus 1. For n is equal to minus 1, these formulas are not valid. Okay, so which formula we will apply here? The second one. Okay, so 20,000 as it is. Now this is ax plus 100 power minus 3. So how we do integral? So we will increase the power. Increase the power means minus 3, add 1 in the power and divide by this new power. Minus 3 plus 1, and also we have to divide by the coefficient of x. You can see here in the formula the coefficient of x is a and we are dividing by a. So here what is coefficient of x? Coefficient of x is 1. Okay, so we have to divide by 1. If you divide by 1 you will get same thing, so no need to write. Our limits are 200 to infinity. Okay, so what you can do, like minus 3 plus 1 is minus 2. Minus 2 you can take outside. So if you take this minus 2 outside, you will get 20,000 divided by minus 2, and this is x plus 100 raised to power minus 2, which you can write as 1 upon x plus 100 raised to power 2. Limits are 200 to infinity. So now you can here cancel this 2 with this 20,000. So you will get here minus 10,000. Now we'll put the limits in integration. First we put the upper limit. So first you put the infinity here. If you put infinity here, so 1 upon infinity plus 100, that is infinity. Infinity square is infinity. So you get 1 upon infinite minus, then you put 200 here in this. So you will get 1 upon 200 plus 100, 300 power 2. So 300 power 2. Is this clear? First I put it the upper limit, then I put it the lower limit. Upper limit minus lower limit. Okay. Now minus 10,000 as it is. 1 upon infinity is 0. Okay, minus 1 upon 300 square, that is 90,000. Okay. So now you multiply this 10,000 inside. Minus minus will be cancelled out. 10,000 by 90,000. So that is 1 by 9. So this is the probability that the life of the medicine will be at least 200 days. The second part was B part, you can see here. Okay. You find the probability that bottle of this medicine will have shelf life of anywhere from 80 to 120 days. Now we have to find what are the chances that the bottle of this medicine will live between 80 to 120 days. So in this part we have to find what is the probability that the value of x will be between 80 to 120 days. Okay, students, whether you include this 80 and 120 or whether you do not include this 80 and 120, it will have no impact, because in case of continuity or in case of continuous random variable, the probability at single point is 0. So that is why whether you include 80, whether you do not include 80 does not matter here. Okay. Now, how we find the probability in case of continuous random variable? By doing the integration of the probability density function. Now, from where to where? Here we have to do integral from 80 to 120. So which property I have used in this case? So this third property that is in front of you. Okay, that if you want to find the probability that x is between a to b, you will do integration from a to b of the probability density function. Okay, so now we are doing integral from 80 to 120. Students, because this function is same, we have already done the integration in the first part of the same function. Only limits are different here. Okay, only limits are different. The rest of the function is same. Probability density function is same. So integral will be also same. So what was the integral that we got in the first part? So if you can see here, that was 20,000 divided by minus 2 into 1 upon x plus 100 raised to power 2. So directly I am writing from there, minus 20,000 divided by 2. It was 20,000 divided by minus 2. I have written minus outside. 1 upon x plus 100 whole power 2. And limits are, earlier limits were 200 to infinity. Now limits are 80 to 120. So is this clear to all what I have done? Because integration is same, na?
Yes.
Same function is there. So same answer will be there. Only limits are different. So now we need to put the different limits. Okay. So again, same, this will be cancelled out. So you will get minus 10,000. Now first you put the upper limit in place of x. So if you put 120 here, you will get 120 plus 100, 220 power 2. So 1 upon 220 power 2, upper limit minus. Now put the lower limit 80 here. So 80 plus 100, 180 power 2. Okay. So what we can do after this? So minus 10,000 as it is. Okay. So if you see carefully, I think you have here 10 square, right? So 10 square means 100. 100 is common in both the from first and second. And second thing is 4 is also common. So you can take here 400 common. So what you will left with here? Here you will left with 11 square, and here you will left with 9 square. Is this clear what I have done? Okay. If you open the square of this, okay, so you will get 100 and you will get 100 right here. So 100 I have taken out and 2 was also common, but you have square here, due to which 4 will come out. The proportion of people who respond to a mail order solicitation is a continuous random variable x with f of x. F of x means probability. F of x is used for the probability density function. So this is PDF. PDF is given. Okay, small f of x will be used for the probability density function. And first we have to show that total probability is 1. It means like if you do, first we have to show. So first part, you have to show that probability that x is between 0 and 1. This probability is equal to 1. First we have to show this. Okay, so let us understand the question first. The proportion of people who respond to a mail order solicitation is a continuous random variable x. So what is random variable here? X is proportion of people who respond to certain mail order solicitation. Student, what is mail order solicitation? So whenever we send mails in bulk to other person, other people. Okay, lot of people. Suppose we are sending mail to 100 people in bulk. Now this mail may be spam mails, but these may be mails which are demanding some kind of money from the other person. Okay. So now suppose somebody sent 100 mails. Now, what are the possibilities? How many people are responding? It may happen that out of 100, 50 are responding back. So if 50 are responding back out of 100, it means half proportion of the people is responding. Okay. If all 100 are responding back, it means full proportion. That means one proportion of the people is responding. If 25 people out of 100 are responding, that means one fourth proportion of the people is responding. So proportion of anything is always between 0 and 1. So suppose we have an apple and we make two equal parts of it, and each part is half proportion. Okay. So when we send mails, in bulk, okay, to other peoples. So how many, what proportion of those is responding back? That is our random variable x. And in the first part, we have to show that that probability that x will be between 0 and 1 is 1. Okay, so very simple. So how we find the probability that x is between 0 and 1? Third property. To find the probability, we have to do the integration of probability density function. So I'm taking this left hand side of this equation and I will show this is equal to 1. And what should be the limits of this left hand side? So student, do tell me what will be the limits here? Limit of the integration?
0 to 1.
0 to 1. Okay. So we will do integral from 0 to 1 and we will show that this integral is coming out to be 1. Okay. So this is equal to, what is f of x? So f of x is here in 0 to 1, the function is 2 upon 5 x plus 2. So 2 upon 5 x plus 2. 2 upon 5 was constant, so I have taken outside. Now 2 upon 5 as it is. Now what is integral of x? This is x power 1, you can say, right? What is integral of x power 1? Increase the power means make the power 2 divided by this new power 2. Plus, what is integral of constant? So this I have not told you this formula. So if you have any constant and you want to do its integral, like if you're doing with respect to x, the entire answer will be constant into x. Okay. So this is the formula for integration of constant. So we have constant 2 here. So integral of constant is constant into x. Now limits are 0 to 1. So now we just need to put the limits in the integral in the this. So first we will put the upper limit in place of x. So you put x 1. So you will get 1 by 2 plus 2 into 1, that is 2. So upper limit put it. Now put the lower limit 0. So if you put 0 here and if you put 0 here, you will get 0. So upper limit minus lower limit. Now take the LCM. So 2 by 5 as it is. So if you take the LCM here, you will get 1 plus 4 divided by 2, which is 2 by 5 into 5 by 2. So 2 to cancel, 5 5 cancel. What we got? 1, which is equal to right hand side. So this is what we have to show in the first part, that probability between that x is between 0 and 1, probability is 1. Any doubt in this, students? Is this clear to all?
Yes, sir.
Okay. Now B part. Okay, so P part is we have to find what is the probability that x will be between 1 by 4 to 1 by 2. So students, here it is mentioned in this way, but in the actual question, the second statement is mentioned how. So they are saying find the probability, what is the chances that the proportion of people who respond to this kind of mail order, they are saying what are the chances that more than one fourth of the people, but fewer than one half of the people will respond to the this type of mail order solicitation. So they have not given this directly. So they have given this in the statement. Okay, means in the words they have given. So you have to know that they are asking this thing. Their words are find the. Let me tell you the exact words I have sent you. This is in the practice questions. So exact words are find the probability that more than 1/4, but fewer than 1/2 of the people contacted will respond to this kind of mail order solicitation. And so you have from there you have to convert that they are asking you to find what are the chances that the number of people who respond is more than 1/4 and less than 1/2. Do you understand what I am trying to say here? Here in this question, it is directly written find the probability that x is between 1/4 to 1/2. Okay, but in actual problem, it is not in written in this way. They have written the words, and we have to make this expression. Okay, so how we find the probability from the probability density function? By integration. Now from where to where we have to do 1/4 to 1/2. 1/4 to 1/2. I am doing the integral of what? Of the probability density function. Okay, 1/4 to 1/2. What is the function? Okay, students. Again, I will use the same logic. You can see that this function we have already done integration here. The same function is same now. So we have already done the integral. So can we directly write this? Only limits are different now. Earlier limits were 0 to 1. Now limits are 1/4 to 1/2. Okay, so you can directly write it will be 2/5 x square by 2 plus 2x, and limits are now 1/4 to 1/2. Now we will first put the upper limit. If you put the upper limit, you will get here. If you put here 1/2, you will get 1/4 into 1/2, 1/8. And if you put 1/2 here, 2 into 1/2 is 1. So upper limit minus lower limit. Now put the this 1/4 here. So 1/16 into 2, 1/32. And if you put this here 1/4, you will get 1/2. Okay. Now we just need to do a little bit plus minus. So 2/5. This was easy. Take the LCM here. So 8 plus 1, 9. 9/8 in the first part. And if you take the LCM in the second one, you will get 16 plus 1, 17/32. 17/32. Again, take the LCM. LCM is 32. So this will be 9 into 4. 36 minus 17 upon 32. Okay, so is this correct? If I can make the mistakes, okay, plus minus. Please do tell me if I am making some kind of mistake there. Okay, so 36 minus 17. So 19, and you can cancel out this 2 and 32, 16. So 19 upon 80. I think this is correct answer. Okay, so probability that 1/4 to 1/2 is 19/80. Is this question clear to all the students, or is there any doubt?
Clear,
Is
sir.
there any clear? Okay. Students, now I will move to the next thing. The next thing is I want to tell you about the combinations. Okay. So suppose there are 4 chairs. Chair 1, chair 2, chair 3, and chair 4. Okay. And I have 2 students. Student 1 and student 2. Okay. And I want these 2 students to sit in these chairs. And in how many different ways these students can sit on these chairs. Okay. Here order does not matter. Order does not matter. Means if student 1 is sitting in the first chair and student 2 is sitting in the second chair, or student 2 is sitting in the first and student 1 is sitting in the second, that will be same. Okay. So if you want to find this total number of ways in which these two students can sit in the 4 chairs, for that we have a very good symbol that is called combinations. So how, if we find this 4C2, what is the meaning of 4C2? So 4C2 means like if we have four things, like these four chairs, 1, 2, 3, 4, and we want to pick two chairs for these two students, then in how many different ways we can do it? So in how many different possible combinations are there? Okay, that we can find with the help of 4C2. This concept will be used multiple times. Okay, suppose I have three markers, marker 1, marker 2, marker 3, and I have to pick two markers. Then how many different combinations are possible? So that is three marker are there, and I have to pick two. That is 3C2. Okay. So for example, first option is I can pick first and second. Okay. Second option is I can pick first and third. And third option is I can pick second and third. So there are only these three options. These three options. Okay. Option 1, option 2, or option 3. Or you can say these three combinations are there. Okay. If we want to find this number, we can find using 3C2. Okay. Now what is 3C2 or NCR? How to compute it? So NCR is n factorial divided by r factorial into n minus r factorial. Okay. So for example, if I have this 4C2 and I want to compute its value, so what I will do, 4 factorial divided by 2 factorial. Okay, here n is 4 and r is 2. Okay, into n minus r means 4 minus 2 factorial. So what is the meaning of factorial? So like 4 factorial means 4 into 3 into 2 into 1. Okay, so 4 into 3 into 2 into 1. So 2 factorial means 2 into 1. Again 2 factorial. So this 2 and this 2 will be cancelled out. 4 and this 2 will be cancelled out. So we got 2 into 3, 6. It means I can select two chairs out of four chairs in total six number of ways. So total six combinations are possible. If I want to select two chairs out of these four chairs, total six combinations are possible. Only six combinations. Okay. In the same way, I can calculate this 3C2, 3 factorial upon 2 factorial into 3 minus 2, that is 1 factorial. So if you open out this, you will get 3. And I have already told you there are three combinations possible. Okay. Now, suppose I have n students. Let us say 10 students. Instead of n, let me use this 10 students I have, 1 to 10. And my simple question to you is, if I want to ask question to one student out of the 10, I have total 10 students and I want to ask a question from these 10 students. So how many different options I have? So you need to tell me this. There are 10 students and I want to ask question from one student. So in how many different ways I can do it?
10.
10, right? Either I can ask the first student, or I can ask the second student, or I can ask third, or I can ask the 10th student, right? Or this we can do it like 10C1. If you find out the value of 10C1, that is 10 factorial divided by 1 factorial into 9 factorial. If you open this 10 factorial, so you can write this as 10 into 9 factorial divided by 9 factorial, 9 factorial, 9 factorial cancel out, so you get 10. Here I want to give an important message that if I have 100, even if I have 100 students and I want to ask question from one student, I want to choose one student out of 100. So how many different options I will have? 100. Okay. Or I want to say that if we have n number of items and I want to pick one item out of those n items, so how many different options I have? The answer is n. NC1 is always n. Okay, NC1 is always n. Second thing, NC0. NC0 is always 1. NC0 is always 1. Now suppose I have 3 students and I want to ask question from 3 students, not 1 student. I want to ask question from 3 students. Or you can say I have 3 students, I want to select 3 students. Then how many different combinations are possible? 3 students are there and I have to select 3 students. How many different combinations are possible?
1.
1. Only one combination. That is select all 3. Only this combination is possible. In the same way, if I have 10 students and I have to select 10 students, what is the option I have? Only one option, select all 10. If I have 100 students, I want to select 100 students. And then only one option, then select all 100. So what I want to say here, if we have n things and we have to see how many combinations are possible of n things, selecting n things together, there will be only one combination. That means NCN is 1. Okay. Actually, I want to use this concept of combinations in my next question. That is why first I have explained the concept of combinations. Okay. So when we use this concept of combination, when we have, let us say, 40 things and we want to select 4 things and we want to know in how many different ways we can do it. That is 40C4. Okay. Whenever we have to choose the things out of multiple things, then we use the concept of combinations. Okay. So NCR tells number of possible combinations of R things out of n things. Means total there are n things and we are choosing R at a time. Then how many different combinations are possible? How many different ways are possible? That is given by the combination. So my next question is I want to discuss from the discrete. A shipment of 7 television sets contains 2 defective. So there are 7 television sets in total. Okay. Total there are 7 television sets and out of 7, 2 are defective. Okay. A hotel makes a random purchase of 3 sets. Hotel makes a random purchase of 3 sets. So means out of these 7s, the hotel purchase how many? 3. If X is the number of defective sets purchased by the hotel. So what is X? Number of defective sets purchased by hotel. Okay. Find the probability distribution of X. Find the probability distribution of X. So if you remember from my yesterday lecture, what is the meaning of probability distribution? Because it is a discrete case, finite number of cases are there. Okay. So probability distribution means first of all, we will find probability for different values of X. So I want to ask, what are the possible values of X? X means number of defective sets purchased by hotel. So what are the possibilities? Now I am saying only one student is answering my questions. I want other to respond. No, what are the possibilities? Like if you are purchasing 3 televisions from a shop,
Okay, sir.
uh,
Well, all
uh,
three could be
defective,
working fine.
all
All three,
three,
no, all three could be working
no,
fine, and
okay,
then
right,
two could be defective and one could be fine, and one could be
mm,
defective, two will be fine.
right,
Only these three probabilities I think are there.
right, good. Okay. So first possibility is there is no defective, means 0 defective. Second possibility is out of the 3 purchased, only one is defective. Second possibility is out of 3 purchased, 2 are defective. But now more than 2 cannot be defective, right? Because there are only 2 defective out of 7, right? So that is why 3 is not possible. Now we are asked to find the probability distribution. Probability distribution means we have to find what the chance that x is 0. What are the chance that x is 1? And what is the chance that x is equal to 2? It means we have to find what are the chance that there will be no defective. What are the chance there will be one defective? What are the chance there will be two defective? Okay. Now, first of all, in how many ways a hotel can purchase 3 television out of 7? If we have 7 things and we want to choose 3 things, how many different options we have? How many different combinations are possible? So that is just I have explained 7C3. If we have 7 things and we want to choose 3, in how many different ways we can do 7C3. Now, what we want? We want 0 defective. Means how many non-defective are there? Total are 7, 2 are defective, non-defective are 5. Now we want that all 3 should be non-defective. So how many ways are there of choosing 3 non-defective out of 5? So that is 5C3. Is this clear to all? Total there are 7 television, and if you want to choose 3 television, so total number of ways 7C3, right? Then I find in how many ways I can choose no defective. No defective means total there are 5 non-defective, and I have to choose 3 television. So that is 5C3. Now we will find the value of this. So 7C3, 7 factorial, 5 factorial, and not factorial, 7 into 6 into 5. 7 into 6 into 5 divided by 3 into 2 into 1. The 4 factorial I have cancelled out. Okay, you remember NCR formula. 5C3 is 5 into 4 into 3 divided by 3 factorial. 3 factorial is 3 into 2 into 1. 2 factorial I have cancelled out. Okay, now let us calculate this value. 3 into 2 is 6. And here let us cancel out this 3 and this 2. So I think we get 5 into 2, 10. 10 upon 35. 10 upon 35. Let me write it here. Okay. Now we will find what is the probability that out of 3 purchased by the hotel, only 1 is defective. If 1 is defective, 2 will be non-defective. So first of all, how many ways are there of purchasing 3 television out of 7? 7C3. Then what we want? We want 1 defective and 2 non-defective. Right? If 1 is defective, obviously hotel purchase 3 television. If 1 is defective, 2 will be non-defective. Now in how many ways we can purchase 1 defective out of 2? So there are 2 defective and we want to purchase 1 defective, and we want 2 non-defective. Non-defective are total 5 and we want to purchase 2. Now we'll multiply this. Why we are multiplying here? Can somebody answer me? I have explained something yesterday to you, and can you answer why we are multiplying this? Which principle we have used here? Now hotel has to purchase defective 1 and non-defective 2. Okay. First we found in how many ways one defective can be purchased. That is 2 are defective, 1 defective, 2C1. Now how many ways 2 non-defective can be purchased? Total 5 are non-defective and we want 2 out of them. Okay. So there are this many ways to do first task. There are this many ways to do second task, and we want both. So we apply the principle of multiplication. Okay. So 2C1 is 2, 5C2. So if you open it, 5C2, 5 into 4 and divide by 2. So it will be, I think, 10, I guess, right? 5 into 4 divided by 2 is 10. And this is 35. So what you are getting? 10 into 2, 20 upon 35. Now we will find what are the chance that out of 3 purchased, 2 are defective. So first of all, in how many ways we can purchase 3 TV out of 7? 7C, 3. Now what we want? 2 defective. How many defective are there? 2. And we want both of them defective. So if 2 are defective, total purchase 3, 1 will be non-defective. How many non-defective are there? 5. And we want 1 out of them. So 2C2 is 1. 5C1 is 5. 7C3 is 35 already calculated. So we got 5 upon 35. Now we have find probability for all three different values of random variable. Okay. So if you write these probabilities in a table, you can also write. So like, let me write it here. What are the values of x? 0, 1, and 2. And you can write the probability of x here. The probability of 0 defective was 10 by 35. Probability of 1 defective is 20 by 35. And probability of 2 defective is 5 by 35. Okay. So this is the probability distribution, this Px for the discrete. Okay. Any doubt any student have? Is this clear to all?
Yes, sir, clear.
Student? Okay. If you can check your answer, you know that sum of all probabilities should be 1. Yesterday I have told you. So you can check that is sum of the all probabilities 1 or not. So 10 plus 20, 30, 30 plus 5, 35. 35 by 35 is 1. So this is correct. Okay. Let us move to the next topic. Okay. So next topic is what is meaning of cumulative distribution function. Cumulative distribution function, or you can say CDF. Okay. So very simple meaning is this. Okay. Cumulative distribution function we denote by capital F of x. Okay. And the meaning is what is the probability that x will have value less than equal to x? What is the probability that x will have value less than equal to x? Like if you are finding f of 2, it means you are finding what are the chance that value of the random variable is less than equal to 2. If you are finding f of 3, it means you are finding what are the chance that random variable will have value less than equal to 3. Okay. Now, if it is discrete, and let me explain with an example. So suppose we have a discrete random variable and its values are 1, 2, 3, 4, and you want to find f of 4. So what will be f of 4? What is the probability that x will have value less than equal to 4? Now what are the values which are less than equal to 4? 1, 2, 3, and 4. So you will find probability of 0, no, so not 0 here, 1, probability of 1, you will find probability of 2, you will find probability of 3, and you will find probability of 4. So what is the point here? If you want to find the cumulative distribution function or CDF, so what you will do, you will add all the probabilities for the values which are less than equal to 4 if you are finding for 4. So here we are finding for x. So what we will do, we will add means sum what? Probabilities. Which probabilities? For those values which are less than equal to x. And if it is, this is for discrete, and if it is continuous, if it is continuous, then how we find the probability for the values which are less than x? In the case of continuous, we do integration. In place of summation, we do integration. Now what is the maximum value? Maximum value is x. From where? Minus infinity to x, or what? Of probability density function. Okay. So if you want to find the cumulative distribution function in case of continuous, you will do integration from minus infinity till x, And in case of discrete, you will do summation for all the values which are less than equal to x. Let me give an example. It will be more clear with the example. Okay. So for example, let us come to this example. If in this question you are also asked find CDF also, find CDF also. Means first they asked to find the CDF probability distribution. Now they are saying find the CDF also in these questions both. So how you will do? So first you will find the probability density function. So I am writing here. What were the values 0, 1 and 2? What were the probability of 0? 10 by 20, 10 by 35. Then probability of 1 was 20 by 35 and probability of 2 was 5 by 35. Now we are asked to find the capital F of x. CDF. This is PDF and this is CDF. So it is very easy. Okay. What we have to do? So first we will find f of 0. Student, what is the meaning of f of 0? F of 0 means what is the probability that x will be less than equal to 0. Now, how many values are less than equal to 0? Only one value is there. That is probability of 0. Now, what is probability of 0? 10 by 35. Now, what is f of 1? F of 1 means what are the chance that x will have value less than equal to 1? Less than equal to 1, which are the values? 0 and 1. Okay. So, what is probability of 0? 10 by 35. What is probability of 1? 20 by 35. Now, you add these two. So, what you will get? 30 by 35. So, f of 1 is 30 by 35. Now, what is f of 2? F of 2 means what are the chances that random variable will have value less than equal to? So 0, 1 or 2. Probability of 0 plus probability of 1 plus probability of 2. So probability of 0 is 10 by 35. Probability of 1 is 20 by 35. Probability of 2 is 5 by 35. So if you add all these three, you will get 1. The last number will always 1. Because what is the last number? Last number is actually sum of all probabilities. Sum of all probabilities, and sum of all probabilities is always 1. So therefore, the last value of cumulative distribution function will always comes out to be 1. Is this clear? Okay, simply for the finding first value, you write the first value directly. For finding second value, you add the first and second value. For finding third value, you add first, second, and third value. In this way, you will do. Okay. Is this clear meaning of cumulative distribution function?
Yes, sir.
Okay. Now, if we are given the probability density function f of x and we want to find the cumulative distribution function, then we have to do the integration. You can see here, right? Now, what if we have to do opposite? Opposite means like what I am saying. I want to tell you relation between CDF and PDF. Is relation between cumulative distribution function and probability density function. So you know that this cumulative distribution function, in case of continuous, I am telling, it is integration of probability density function from minus infinity to x. Okay. Capital F is integration of small f. So if you want to find small f from capital F, what you will do? What is opposite of integration? Derivative. So derivative of capital F. So if you want to find the PDF from CDF, you need to do derivative. Okay, so we need to do derivative if you want to find PDF from CDF. If you want to find CDF from PDF, then you have to do integration. Okay, is this clear? Okay, one more thing, like let us do some example so that the examples are important, I think. Otherwise, only concept will not able to help you. Okay, just 1 minute. Let me see some example. Mm, okay, so let me first. I am trying to put one. Now I'm not doing the example of CDF. First, I'm doing one more example of the PDF. Okay, just 1 minute. I'm taking the screenshot of the problem. So two problems I am putting together. They are different. Okay, let me post these problems here. Student, first we will do first question, then we will do second question. Okay. So what the first question is saying, a continuous random variable x has the probability density function PDF. F of x is given, where x is between 0 and 1. Find the value of a and b such that probability that x is less than equal to a is same as probability of x greater than a. So first part I am solving. So what we are given here, probability of x less than equal to a is same as probability of x greater than a. Okay, and we are given the PDF, probability density function 3x here, and the value of x is between 0 and 1. This is important. Okay, now so how we find the probability in the continuous case? Because it is a continuous random variable, it is mentioned in the question, by doing the integration. So maximum value is a, so we will do integral till a. What is the minimum value? So the value of x start from 0 and goes till 1. So the minimum value of x is 0 of probability density function f of x. This is equal to, now for x greater than a, so minimum value is a and maximum value of x. Maximum value of x is 1. Okay, f of x dx. Is this clear, this logic here, or is there any doubt in this one? Student, are you able to be, some students are not responding. So my question is simple. Are you able to turn on your mic, or some permission is required from my side? Divya, Divya. So can you, is this clear to you? Hitesh, Aditya? Yes. Okay, they're saying yes. Okay. Now, what is the function? Function is 3x square. Okay, so now we'll put the in place of f of x, we'll put here 3x square. We will do integration from 0 to a dx is equal to a to 1. Function is 3x square dx. 3 is constant, 3 will come out. Integral of x square we have to do. Same thing on the right side. 3 is constant, 3 will come out. Integral of x square we have to do from a to 1. So this 3 and 3 will be cancelled out. Now what is integral of x here? Okay, what is integral of x here? So I have told you this formula, students. Integral of x power n is increase the power divided by new power. So okay, so first we will do integral of x here. So what is the integral of x here? Increase the power 2 plus 1 3 divided by new power 3. Now limits are 0 to a, and on the right side we have in same x cube divided by 3, limits are a to 1. Now first we will put the upper limit. If you put the upper limit here, you will get a cube by 3. If you put the lower limit 0 in place of x, you will get 0. And now on the right hand side, first put 1, you get 1 by 3. Then put the lower limit a, so you will get a cube divided by 3. Now send this a cube divided by 3 on this side. So it will be added here. So you will get 2 times a cube divided by 3 is equal to 1 by 3. So this 3 cancel out. You get a cube is equal to 1 by 2. Or you can say a is equal to 1 upon 2 power 1 by 3. Are you getting the same answer? If you have tried.
Yes, sir, same.
Okay, good. Okay, so now second part. Second part is we have to find a and b. In the first part we have found a. In the second part we have to find the value of b such that probability of x greater than b is 0.05. So what we are given? We are given that probability of x greater than b is 0.05. Now because it is continuous random variable, it is mentioned in the question how we find the probability by doing the integration. Integration of probability density function. Now from where to where we have to do? The minimum value is b. The minimum value is b. And you can see in the question the maximum value of x is 1. Okay. So we have to do integration from b to 1, and this is given equal to 0.05. Again same logic will be used. 3 is constant. So let me write this in a proper way. B to 1, 3 x square dx is equal to 0.05. 3 is constant, 3 will come out. Okay, integral of x square, increase the power divided by new power. Limits are b to 1 equal to 0.05. Now this 3 cancel out. Put the value, so you will get 1 minus b cube equal to 0.05. Now send the b cube on other side and 0.0 on this side. You will get b cube is equal to 1 minus 0.05, which is 0. B cube is 0.95. Okay, so b is cube root of 0.95. Okay, so is this clear? Okay, now I will do the second question. Okay, the waiting time x in hours between successive speeders has the CDF. Now in this question, PDF is not given. We are given the CDF, cumulative distribution function. Find the probability of waiting less than 12 minutes. Okay, so this is incomplete question. Okay, so let me explain you the statement. The complete question is, there is a radar unit. Okay, there is a radar unit. What this radar do? It detects fast moving vehicles or speeders. Speeders. So when what will happen? Once first speeder will come, after that there will be second speeder. Now, between this first speeder and second speeder, there is some waiting time. Waiting time. Waiting time between successive speeder. This is given to be random variable x. We are given that what is x? X is waiting time between two speeders. Means how much we have to wait. Okay. And we are also given the cumulative distribution function f of x, CDF. Not PDF, I am repeating, it is CDF. CDF is given as the CDF is 0 if x is less than 0 and 1 minus e power 8x minus 8x. So it is 0 if x is less than equal to 0 and it is 1 minus e power minus 8x if x is greater than 0. Okay. So this we are given CDF, and what we are asked in the first part, find the probability of waiting less than 12 minutes using CDF. Okay. So we have to find what are the chance probability of waiting less than 12 minutes. Okay. So I want to seek your attention on this word minutes. Okay. Why I'm saying here? Because in the question, the waiting time is measured in hours, and they are asking us in minutes. X is in hours, but they are asking us probability of waiting less than 12 minutes. They are asking in minutes, but X is in hours. So first we need to convert this 12 minutes in hours. Okay. So if we convert this 12 minutes in hours, so you know that in 1 hour, so you have 60 minutes. So 1 minute is 1 by 60 hour. So 12 minutes will be 12 by 60 hours. So if you cancel out this, it is actually 1 by 5 hour. 1 by 5, or you can say 0.2 hour. Is this clear? Why we are converting this minutes in hours? Because X is in hours actually. Okay. So that is why we have to convert this minutes in hours. Now what we are asked? We are asked find the probability that the waiting time is X. X is waiting time between successive speeder. That waiting time is less than 0.2 hour. You don't need to write hour here. 0.2. So X is measured in hours. Do not write 12 here because 12 is in minutes. They asked us in hours. Is this clear? Okay. Now, what is the meaning of CDF? If you remember, CDF means what is the probability of X less than equal to X. So you can see here the definition of CDF. I have told you clearly. CDF tells us what are the chance that P of X is less than equal to X. Okay. Now you have to find what is the chance that X is less than 0.2. So if in the is not the same as f of 2, f of 0.2. What is the meaning of f of 0.2? F of meaning is what is the probability that X is less than equal to 0.2. But as I have told you in case of continuous, whether you include the single point or whether you do not include the single point, both are same thing. Okay. So these two are same. So to find the probability of waiting less than 0.2 hour is same as finding the value of the function at 0.2. Now, what is CDF at 0.2? What is this f of x at 0.2? So you just need to put 0.2 in place of x. So if you put 0.2 here, you will get 1 minus e power minus 0.8 into 0.2. That is minus 0.8 into 0.2, 1.6. So let me write 0.8 into 0.2. So that is 1 minus e power minus 0.16. Is this clear to all? First part. If there is any doubt, please tell. I will explain. I will try to explain again. So, Vishal, is this clear? Mukul Sharma. Okay. Okay. Now second part is using PDF. Means we have to find the same probability, but now we have to use the PDF instead of using the CDF. Okay. You are given the CDF. First we have used the CDF to find the probability. Now we will use the PDF. Okay. So first of all, you have to find what is the PDF. For solving B part, you need to find PDF. Now, what is the relation between CDF and PDF? So I have told you that if you want to find the PDF from CDF, you have to do the derivative of this CDF. Okay. So what is the derivative of CDF? So CDF was 0. So derivative of 0 is 0 if x is less than equal to 0. And this CDF was 1 minus e power 8x. 1 minus e power 8x when x is greater than 0. So if you do derivative of this, derivative of 1 is 0, derivative of constant is 0, derivative of exponential function is itself into derivative of power, which is minus 8. So you will get here derivative of 1, 0. So you will get minus e power minus 8x into minus 8 when x is greater than equal to, when x is greater than 0. So that is 0 when x is less than equal to 0 and 8 into e power, oh, it was minus 8. In the previous part, it was minus 8x, na? And I have made a mistake here. I have written here minus 0.8. But no student is pointing out this. The student, please point out the mistakes. It was 8x, x is 0.2, and so this will be 1.6. Okay. So 8 into e power minus 8x when x is greater than 0. This is density function we have found. But in the question, we have to find what the chance that waiting time is less than 0.2 hour. That is 12 minutes. So in the second part, we have to find it from the PDF. Now PDF, we have first found the PDF from the CDF. Now how we find the probability from PDF? By doing the integration. Integration for where? Which values? Which are less than 0.2. So maximum value 0.2. Now which values are less than 0.2? So because this function is 0 for the negative values, so minimum value is 0. Okay. So you have to do integration from 0 to 0.2 of 8 e power minus 8x with respect to x. Okay. Now I am going to tell you one more formula for integration. Integral of e power ax. Integral of exponential function is itself e power ax divided by this coefficient of x, which is a. Okay, so same here. Integral of e power minus 8x is e power minus 8x divided by the coefficient of x, which is minus 8, 0 to 0.2. So 8 cancel out. Minus you can take outside. First put the upper limit. If you put the upper limit, you will get e power minus 1.6. Then put the lower limit, e power 0. E power 0 is 1. So you will get 1 minus e power minus 1.6, which is same that we got earlier here, you can see. Because same probability we are finding. Only difference is here we are using the uh, CDF, and earlier we are using the PDF, and earlier we are using the CDF. Is there any doubt in this question?
No, sir.
Okay. Now I am going to start this new topic, which is very important. That is expectation. Expectation, or you can say average, or you can say mean value of random variable. Okay. What is the meaning of expectation? What is the meaning of average? What is the meaning of mean? Okay. So all these are same thing. They have different names: expectation, average, mean. Okay. So to explain this thing to you, what I will suggest you. So all students do this activity that in your mobiles. Okay. Or if you are having a laptop open, so what you do, you open a virtual dice. Open a virtual dice, everyone. Okay. Now what you do, you roll this dice 10 times. Roll this die 10 times and note down the numbers that you are getting. So like first number, second number, in this way do it 10 times. Okay. And note down those numbers. Okay. So in this way you have noted down these 10 numbers. Now I ask you to find the average of these numbers. Find the average. Average means here average means just add them and divide by total number of things. So sum of the number 37. How many numbers are there? 10. So I found the average is 3.7. Okay. My claim is most of the students, those who have performed this activity, they will get the average between 3 and 4. 3 and 4. You will 100%, many of the students, those who have done the activity, they will get the average between 3 and 4. Now we are going to learn how we can predict that where will be the average value, and how we can find in different kind of situation what is the expected value. Okay. So it is very nice thing in probability. Okay, so that we call expected value of random variable. So we denote the expected value by mu, mean, or we also denote by E of x. E of x means expected value of x. Now how to find this value? So if it is a discrete distribution, we do sum, and if it is continuous, we do integration for all possible values of x. So for all possible values, minus infinity to plus infinity, whatever are possible. Like I'm writing here minus infinity to plus infinity, but sometime in function is only defined from 0 to 1. In that case, you will do integral from 0 to 1 only. You know? Of what? So you will do sum of x into probability of, and here also in case of continuous, you will do integral of x into f of x. So this formula is for discrete. This formula is for discrete, and the second one is for continuous. Okay, let us understand its applicability or application. So for example, we have done this experiment of rolling a dice, right? So let x be number on dice. Number on dice. So what are the possible values of x? What are the possible numbers that can appear on dice? So either we can have 1, we can have 2, 3, 4, 5 or 6. These numbers can appear. Now what is probability of each of these numbers? Because in a dice all 6 faces have equal chances. So the probability is 1 by 6, 1 by 6, 1 by 6, 1 by 6, 1 by 6 and 1 by 6. So this is the probability distribution of number on dice, right? Is this clear to all? Is there any doubt in this? Now I will find the average number on dice. Okay, or you can say I will find the average of x, or expected value of x. Okay, so let me ask the question. So students, first tell me, is it discrete distribution or continuous distribution? Is it discrete or continuous? Jabel Jaman. Javed Jaman. So is it discrete or continuous? This experiment of rolling a dice. Please tell me. You can write in comments if you are not able to speak. So because it is discrete distribution, so we will apply this formula, first formula, sum of x into px. The sum for all values of x. Now what are the values of x? Values of x are from 1 to 6 of x into px. Okay. So now put the values. First you put 1 into p1, and put 2, so 2 into p2, then put 3 into p3 up to 6 into p6. So what we have to do basically, we need to multiply x with the probability of x. So 2 with probability of 2, 3 with probability of 3, 4 with probability of 4, 5 with probability of 5, 6 with probability of 6. Okay. So probability of all is 1 by 6. So I can take 1 by 6 common. So 1 plus 2 plus 3 plus 4 plus 5 plus 6. So if I add all these numbers, what is the sum of first 10 natural numbers? That is n into n plus 1 divided by 2. So 6 into 6 plus 1, 7 divided by 2. Okay. So if you cancel out the 6, you will get 7 by 2. So it is 7 by 2, 3.5. Now go back to your experiment. So my average came 3.7. And that is why I was sure that many students will get the average between 3 and 4, because mathematically we expect the average should near 3.5. Okay, average should be 3.5 ideally. Okay, but in practical it may be different, but it will not be much different if you increase the number of trials. Like if you do the same experiment 100 number of times, so you will be more near to 3.5. If you do it 1000 number of times, it will be more near to 3.5. Okay, and some students exactly get 3.5 also. So I have done this activity in the class of 70 students, and I asked them. So in my class, almost all the students were getting the number between 3 and 4. Okay. Any doubt in this? Any doubt in this? Okay.
No, sir.
Okay. Now let me ask you a simple common sense question. The question is like, if I toss 100 times a coin, So what do you expect? How many heads will be there? If I'm tossing a coin 100 times, so as per our common sense, how many times we should get head and how many times we should get tail?
50-50, I
Let
guess.
me right, 50-50, because equal chance for head and equal chance for tail, right? So if you are tossing a coin 100 times, we expect 50 times should be head and 50 times should be tail. This is our common sense, right? And so on average, how many number of heads you should get? Average number of heads per toss. How many heads you will get? Means you are doing toss 100 times, you are getting 50 heads. So per toss you will get how many heads? 0.5. On average means you are getting 0.5 heads. Okay, this is the average. Means sometimes you are getting tail, sometimes you are getting head, but on average, how many heads you are getting? 0.5. Okay, like because total number of times you have done is 100, you are getting 50 heads, so 50 by 100 is 0.5. Now let us find, is this coming out if we are doing it with the help of this formula? So let it x denotes number of heads. Okay, so question is, find expected number of heads when we toss a coin. Find expected number of heads when we toss a coin. Okay, so x is the number of heads. Now when you toss a coin, only two possibilities are there, head or tail. So in this possibility there is one head, in this possibility there is no head. So what are the possible values of x? Either 0 head or 1 head. What is the probability of 0 head? 0 head means only tail. What is the probability of tail? 1 by 2. What is probability of head? 1 by 2. So now this is the probability distribution. Now find the expected value of x. So that is sum for all values of x. Values are 0 and 1, x into px. This formula I have used for the discrete. Everybody is with me? This formula I have used, x into px. So x into px, the values of x are now 0 head or 1 head if I'm tossing coin one time. Okay, so 0 into probability of 0 plus 1 into probability of 1. 0 into anything is 0, 1 into probability of 1 is 1 by 2, which is 0.5. Okay, this is the average number of heads that we expect to get when we toss a coin. 0.5, which is a common sense also answer this question. Then why we need this expectation? Why we need this average value? Because in these two problems that I have done here, all the values have equal chances. So we can easily guess, right? But in real life situation, some value may have more chance as compared to other value. Some data may have more chance of happening as compared to other data. So in that case, we want to know what is the expected number, what is the expected value. So let me do one example, one important example from the examination point of view also. So this example I'm going to here. The lot contains 4 good components and 3 defective components. So total there are 7 components, and out of 7, 4 are good components and 3 are defective components. Okay, let me highlight. Total there are 7 components, 4 are good components and 3 are defective components. Okay, a sample of 3 is taken by the inspector. So out of the 7, total are 7, defective are 3 and good are 4. A quality inspector taken a sample of how many components? 3. Out of 7, the inspector taken a sample of 3. Find the expected value of number of good components in the sample. So whenever they ask us find the expected value, then they also tell us whose expected value of number of good components. So we have to find expected value of number of good component. It means what is x here? So x here is number of good components. And what we have to find? We have to find expected number of good components. So means we have to find E of x. Now students, if we have to find the expected value, we must know the probabilities for different possible cases. Okay. Now when the inspector is selecting 3 components, out of these 3 components, what are the possible number of good components? So either there will be no good component, it means all 3 are defective. Okay, so it means x can be 0. Either of the 3, 1 is good component and 2 are bad. So 1 good component in that case. Either we can have 2 good components or we can have all 3 as good. Okay, so now we will find probabilities for the different values of this. What are the chances that there will be 0 good component? So first of all, in how many ways an inspector can select 3 components out of 7? 7C3. Now what we want x is equal to 0 means component. 0 good means we want all 3 components to be defective. In how many ways we can select 3 defective components? So can somebody tell me this? If you are present, please try to participate in this class. Okay, yeah, 3C3, very good. Himanshu Kumar have already written, right? Good. Because there are 3 defective and we want all 3 to be defective, so that 0 is good component. Okay, so if we have 3 things and we want to select all 3, there is only one option, select all of them. And 7C3, as we have already done it earlier also, it was 35, I guess. Okay, now we will find what are the chance of getting one good component out of these 3 that the inspector has selected. So if 1 is good, it means 2 will be defective. 1 good, 2 defective, only then it will be 3, right? Now first of all, total number of ways of selecting 3 components out of 7C3. Now what we want one good component. So how many good components are there? Total 4 are good component. We want 1 good and we want 2 bad, 2 defective. So 2 defective we want. How many defective are there total? 3. Okay. So if you solve this, 4C1 is 4, 3C2 is 3, and this is 35. So we got 12 by 35. Okay. Then in same way we will find what are the chance of getting 2 defective. So sorry, 2 good components. So how many good components are there? 4. We want 2 good. Total 3 are selected. So 1 will be bad. How many bad are there? 3. Now total ways of selecting 3 components out of 7, 7C3. So let us simplify this. 4C2 will be 4 into 3 upon 2. That is 6 into 3 divided by 35, which is 18 by 35. Now we will find what is the probability that all 3 will be good components. So first of all, total number of ways of selecting 3 out of 7, 7C3. How many good components are there? 4. And we have to select all 4 good. All 3 good, sorry. We have to select 3 good component out of 4. Because inspector is selecting all the 3 components. Okay. 4C3 is 4. 7C3 is 35. Okay. So we have found the probabilities for all different values of random variables. If you want to check whether you have found correctly or not, what you can do? So you can add all the probabilities, sum should be 1. So 1 plus 12, 13, 13 plus 18, 31, 31 plus 4, 35. 35 by 35 is 1. Okay. So you can write here x and px. X values were 0, 1, 2, and 3. Probability of 0 was 0 good component was 1 by 35. Probability of 1 good component 12 by 35. Probability of 2 good components 18 by 35. Probability of 3 good components 4 by 35. Okay. So this is the probability distribution we have found. Okay. Why we are finding probability distribution if we are asked to find the expected number of good components, then why we are finding this probability distribution? Okay. The answer is because in the formula we need x into px. And if you want to find the expected number of good components, expected value of x, what is the formula? Because it is discrete distribution, so we will do summation of x into px. You need the px. That is why we are finding the probabilities, right? Now, what are the possible values of x here? 0 to 3. So 0 into probability of 0 plus 1 into probability of 1 plus 2 into probability of 2 plus 3 into probability of 3. Okay. So basically you have to multiply 0 with probability of 0, means 0 with 135, 1 upon 35, 1 with 12 upon 35, 2 with 18 upon 35, 3 with 4 upon 35. And then you have to add. So 0 into anything is 0. 1 into 12 by 35. So you will get 12 by 35. 2 into 18 by 35. That is 36 by 35. 3 into 4 by 35. So 12 upon 35. So 12 and 12 for 24 and 36. So which is I think 60 by 35. So you can cancel it out 12 by 7 or you will get 1.771. Okay. So this is the expected number of good components. That if an inspector will take the sample of 3, then we expect in sample of 3 there will be 1.71 components which will be good components. So now my question to you is how it is possible? Means 1.71 component either will be one component or there will be two component or there will be three component. So how 1.71? Same way, like when inspector choose a component, sometime it may happen that he get three good component. Sometime it may happen that he get only two good components. Sometime it may happen when he is choosing three components, only one is good component. But on average, we expect the average number of good components will be 1.7